Hello, everyone. My name is Kevin Lance, and I'm a marketing director at Unchained Labs. I'll be your moderator, and let me be the first to say thank you for joining us today. We'll have a Q&A session at the end of the presentation. To ask questions, all you have to do is click on the Q&A button in the Zoom navigation bar at the top or bottom of your screen and type in your question. When submitting a question, please avoid clicking the anonymous button so that way we can reach out via email if we aren't able to get to your question live. We will get to as many of those as we can. Now, I'd like to introduce Nellis Dennis, Product Manager for Stunner at Unchained Labs. Today, Nellis will walk us through how Stunner's technologies provide a unique characterization tool for high throughput and low volume LNP size and total RNA concentration. And now I'll hand it over to Nellis. Nellis, how's the weather in Belgium today?
It's the first sunny day of the season, I would say. Finally, no rain anymore.
Congratulations. All right, Nellis, take it away.
Okay, I would like to start with thanking everyone again for joining this talk. So welcome to the seminar, Level Up Your Nanoparticle Quant and Sizing on Stunner. So overall, you're not you when you're hungry. Jean-Claude Van Damme here, famous Belgian, can't seem to find his Snickers anymore and wants to check if this guy ate it. But there are less invasive techniques to check that. To me, that sounds similar to nanoparticle characterization. It just doesn't make sense that you need to break down your particle every time you want to know what is actually inside. And overall, there's a lot of properties that are important during development of nanoparticles. What particle shape you want and what size they should have, which lipids or other components will be used, and in which ratios. Choosing your API payload, choosing surfactants, what charge the particle should have, and so on and so on. But once the particle is made, two important questions come up as well. What is my particle's payload concentration, and does it have the size I want it to have? Nanoparticle size is critical to the performance of a successful drug. So when you got lots of buffers, formulations, and RNA constructs to test, you want to be gathering size data on everything. But the current techniques used to answer these questions are overall slow and painful. Getting nanoparticle size with traditional DLS systems is one by one, it requires large volumes, and it's overall slow. While getting your payload concentration requires you to destroy your particles so you can run a fluorescent dye that also needs standard curves, that is just a hassle. And that's where Stunner tackles these two questions simultaneously. With our nanoparticle applications, Stunner delivers low volume, high throughput DLS without the need for dilutions to get the size and PDI data you need. And on the same 2 microliter sample, Stunner will quantify your total payload concentration, whether it's RNA, DNA, protein, or any active pharmaceutical ingredient, without the need for any reagents, standards, or fluorescent dyes. All this is done in a 96-well plate-based format that powers high throughput analysis of your nanoparticle samples, fresh out of mixing. So how does that all work? Stunner contains two technologies to read each sample. It will do UV-Vis for concentration and DLS for size. You simply add in 2 microliter of your nanoparticle into the input well, and it's going to be pulled into the microfluidic reservoir. At this step, your sample can sit up for 2 hours without evaporation. After the plate is loaded into the instrument, the circuit is going to be read first when it's still empty, and that will remove any contribution of our consumable. And then a pump applies a small vacuum which moves the sample into the microcuvettes for the actual measurement. Because our circuit has fixed path lengths, it can make very precise and accurate reads. Stunner's nanoparticle applications combine both technologies on a sample to deliver total payload concentration and low volume, size, and PDI results. And here we can see exactly what sample loading looks like with the help of some fluorescein and a black light. In 2 wells, we've already added 2 microliter of fluorescein, as you can see. And now to load another sample, you simply add in that 2 microliter into the input well, and it automatically goes into the plate. Simple as that. And on the left, you can see loaded samples, while on the right, you can see the samples after being measured with Stunner. The 2 diamond shapes are cuvettes for 1 sample. What this also shows is that after pumping, all the sample remains in our consumable, so there's no contact between the sample and the actual instrument. There's no contamination possible. So LNP size is critical to the performance, as I said before, so throw a stick in the literature and you'll hit a paper with LNP size data, often showing the link between size and the effective dose needed. Now, on Stunner, you can do 96 at a time. We're looking at intensity distribution here for a whole plate of nanoparticles, with a z-average diameter noted directly below each distribution. And Stunner will provide DLS results just how you like it, with the hydrodynamic diameter and with PDI. But now you no longer have to be limited by DLS data that has to be manually gathered for about a dozen pieces of data in a day. Now your DLS can actually keep up with your nanoparticle samples as fast as you can make them, also allowing you to run as many replicates as you want. And so here we're looking at mRNA LNPs with about 79 nanometers of hydrodynamic diameter, plus or minus 1%, and the PDI was around 0.14 plus or minus 0.02. So you get that high throughput power for sizing on 96 samples in less than an hour, and it's practically 10 minutes of hands-on time. And Stunner will do all the rest in about 45 minutes. While other instruments will be one by one, resulting in more than 3 hours hands-on time to get DLS on 96 samples. In this example, we want to check different buffers and want to measure the size for each formulation. The issue with some existing DLS systems is that you need to dilute your sample to be able to measure your size first of all. However, a dilution in a certain buffer can also result into different sizing, making it difficult to judge if your size is now influenced by the dilution or by the formulation. And so you actually don't know the size of your stock solution. If we start with a stock solution in PBS, which is the yellow line here, the size was measured in triplicate. Then the stock was either further diluted in water PBS or 5.5x PBS. The viscosity was, of course, corrected accordingly. It is clear that with diluting the sample, nanoparticle size is changing. So watch out with other systems that require dilutions to measure your size, since the dilution itself can affect your results. Stunner allows you to measure your stock, but also to quickly check in which diluent your particle size stays the most stable. Okay, now let's focus in on the quant part, how to use Stunner to get the payload concentration of your nanoparticle. The most famous product with nanoparticles is for sure still the mRNA vaccines. An important factor is the dose, of course. Dye-based quantification is multi-step. It requires dilutions. It uses costly standards and dyes, and it requires hours of analysis and hands-on lab work, which includes breaking down that precious particle you just made. There needs to be a better way. And you could try classic UV-Vis, but nanoparticle solutions have so much turbidity in them that traditional UV-Vis approaches fail. That's until Stunner. You can load up your nanoparticle sample into our sample well, and you can see it quickly going into the reservoir. There we have the two cuvettes, the 1.1 millimeter and the 1.7 millimeter pad length microcuvette. Now, when reading these LNPs, the combination of those makes a very nice precision and a very broad dynamic range. These LNPs are very turbid, cloudy samples, and so the short path lengths that we have are needed so that light can still pass through and enable absorbance measurements. Now, let's look at some RNA LNP samples. You can see the empty LNPs on the left create a whole lot of signal that looks like absorbance, but it's actually turbidity. And usually that's not helpful at all. It just gets in the way of your reading. And that's because all that turbidity, because of that, quantifying on traditional UV-Vis is almost impossible. Total RNA quant by UV-Vis is just a big challenge. For example, if we really look finally at the full curve, we can see the RNA bump at about 260. There's also a ginormous green arrow towards it, but the difference is pretty small. So to analyze this, you have to separate the signal from the turbidity from your actual LNPs to what's coming from your RNA. And with traditional UV-Vis, that would require you to pretty much blank with the exact same amount of particles as your full thing, which is just pretty much impossible. Now, on the left, we have that raw data again. And on the right, Stunner has used our Unmix algorithms to isolate the impact of turbidity and actually remove it. So this is shown by the black line indicating the total signal. And then you have the gray line that indicates the contribution from the turbidity. What is remaining is green and blue. Green is the isolated signal from RNA, and what we're, of course, interested in for the total RNA concentration. And blue is the UV-Vis absorbance signal from other components in your sample, like lipids, excipients, your buffer components. So Stunner will separate the contributions of those three groups, your turbidity, your RNA, and anything else in your sample, to quantify the total RNA in your sample in less than a minute from that 2 microliter without any dyes, reagents, complicated workflow, or breaking down your capsid. Okay, Stunner's RNA concentrations agree closely with the total mRNA concentration determined by Ribbergreen for these samples. Twofold dilution series of Firefly luciferase is also shown, and that showed highly linear results down to 1.2 microgram per ml. The error bars here are plus or minus 1 standard deviation. And as mentioned, Stunner lets you run 96 samples in an hour. So here we can see 96 replicates of that RNA LNP, where the green is your RNA concentration, shown below the bar and also green in the graph. And the gray is the turbidity signal. The coefficient of variation is a spectacular 1.54% over these 96 complicated samples. And so quant exactly like you want. Using Ribbergreen to quantify your RNA means you'll need to lyse your particles, use 2 standard curves with costly standards. And basically to measure 4 samples, you'll end up measuring 96 samples if you include all the standards and the controls you need. While doing 4 samples on Stunner is simple, dye, and standard free, and you don't even need to break down. You'll get your RNA concentration and size for those 4 samples in about 4 minutes. RNA LNPs are, of course, not the only nanoparticles out there. As mentioned in the very start of this presentation, there's a bunch of different things you can do with nanoparticles. And so let's take a look at some other potential payloads. So these graphs show results from Stunner on either a nanoparticle, a lipid nanoparticle containing DNA or containing protein. Stunner will apply the same algorithms to remove the turbidity signal so you can get accurate DNA or protein concentration, again, without dyes or breaking anything down. And it doesn't stop there. Any one of you out there are making all kinds of nanoparticles. So Stunner allows you to customize its algorithms for your specific thing. Simply tell Stunner what to look for and the software will do the rest. So let's zoom in on the relevant part of the spectrum and see what Stunner finds in this protein RNA LNP. So this is a combination of protein and RNA in a nanoparticle. Stunner will again unmix the turbidity signal and the protein and the RNA signal. So that's allowing you to quantify whatever you want. Here you can easily get the protein concentration. But if you want to flip-flop and quantify your RNA payload instead, that's no problem. With some clicks of a button, you can easily recalculate your measurement and you'll get those results as well. And again, anything with nanoparticles goes, so anyone's making all kinds of things, unique proprietary particles out there with custom payloads. And so you can teach Stunner all about the UV-Vis absorbance of both your payload, but also from your nanoparticle. So shown here is a setup in the software and the results where Stunner allows you to create your own reference spectrum. We're looking at the absorbance of empty MC3 lipid nanoparticles. You simply need to dilute, for example, you simply need to dilute the empty nanoparticle and Stunner will extract the reference spectra out of it. You only need to do that once. And then you can use that further in Unmix to split the signal between this particle and whatever payload you're going to put in, providing the possibility to set up your custom application and quantify exactly what you're interested in. So we're looking at these MC3 particles and they have high absorbance over our complete spectrum of interest. We took the MC3 reference spectrum from earlier and Stunner nicely deconvolutes that from RNA and turbidity. So this allows you to quantify the payload of practically any particle, even when your particle itself is absorbing. And again, without the needs to break down or use standards or dyes. We also have IQOQ procedures available, and our Stunner software has a 21 CFR Part 11 compliant add-on with full audit trail and electronic signature capabilities. And for anyone doing manufacturing, quality assurance, quality control, we also have performance verification Pretty much these tests meet the United States Pharmacopoeia, the European Pharmacopoeia guidelines for UV-Vis systems. And so all the tests and necessary calculations are all automatically done by the software, giving you nice reports on the results. So Stunner's nanoparticle applications combine both UV-Vis and DLS technology on a sample to deliver total payload quantification and low volume size and DLS results, and PDI results, sorry. And so that's how Stunner delivers label-free, standard-free, and hassle-free gene therapy. So just like our good friend Jean-Claude here, he wants to keep his zen by knowing how many Snickers he has without resorting to the drastic methods of earlier. You can keep your zen while making nanoparticles by getting size and quantification information from Stunner's flexible nanoparticle apps. Thank you for joining this talk. We're going to go to the Q&A now, but always feel free to reach out to our website.
All right. Thank you, Nellis, for introducing us to Stunner and how it's being used for high-throughput DLS, UV-Vis for rapid and very precise nanonucleic acid quant, and even how Unmix makes Stunner a flexible analysis platform for any particle or conjugate. So we've had some great questions that have already been submitted. You can still ask a question out there in the audience by entering it in the Q&A section of your Zoom navigation bar. So Nellis, first off, can Stunner be used immediately after nanoparticle assembly?
Yes. So before you actually go into dialysis or anything, you can just run it on Stunner. The main thing there is it can't have more than 25% ethanol. That is not compatible. But otherwise, you can just run it. And if you're more interested in ways to assemble nanoparticles, I would say check out our nunchuck instrument as well.
Yeah, that's true. It's our LNP maker. So another question, do I need a new experiment for each formulation?
No, so you have 96 sample options, and you can actually split that in 12 different groups. So if it's a different lipid or anything like that, you can just say this group, this lipid, and measure it all at once with the same application at the same time. So you can just load everything and put it in the system and go have your coffee.
The coffee is the important part.
Definitely.
All right. So a question, kind of going back to the earlier part of the talk, can you quickly review the consumables associated with the instrument? And then is each well in that 96 well plate reusable? And if it's not reusable, what's the cost?
So it's a plate-based format. It's SBS compliant, so you can load it with any multi-channel or liquid handler, as long as it can do 2 microliters. And so you have 96 wells. It's 2 microliters, as I just said. And then, each position, since we need the empty measurement of that position to get the best results out, you can only use each position once. You don't need to use the whole plate at once, so you can use any sample between 1 and 96. But otherwise, it's not reusable.
Okay, so kind of normal 96 well plate rules.
Yes, exactly.
All right. Is an empty nanoparticle needed to blank?
So no, everything is in the software. Overall, you just start with our default setups. Only if you really would add on excipients or anything like that to your nanoparticle and they absorb, then you would see that it doesn't work in the normal setup, and then you need to measure your empty nanoparticles once in a dilution series, and then the system does all the rest again. So only once maximum, only if it absorbs, which is
yeah. And there's kind of a related question that talks about how the absorbance from the blank nanoparticle is affected by dilution, but really we're not subtracting the blank from the full, correct?
Yeah, so the reference spectrum we have is concentration independent. So that's the good thing about it. You don't need to have the exact same amount of it. That's why if you need to store an empty, your empty nanoparticle, again, because it's a special custom thing, that's not by default, then you dilute it once so we can get a reference spectrum that fits any concentration.
Okay. There's a question, do we have any data examples on specifically encapsulating small molecules contained in liposomes or LNPs?
Sorry, can you repeat that?
So the question's about small molecules. We talked about protein and RNA and DNA. Is there any data that we've shown on small molecules?
Not in here, but we have data on, for example, doxil as well, inside nanoparticles. So reach out, I would say, and we'll send that over.
Yeah, and I'll say for that particular question, that user was anonymous. So if they follow up by email to info@unchainedlabs.com, we'll reach out and share that data with you. Okay, so related to that, can this technology be used for other carriers like viral vectors?
Yeah, so the essence of the instrument is, of course, the UV-Vis and DLS. So we have great applications for AAV and adenovirus, where you can get capsid titer, genome titer, all at the same way, no needs to break down or anything. And that can be applied to other viral vectors. For example, the last thing I want to add, if you would have lentivirus vectors, I would say check out our Leprechaun system that's specifically for titers on lentiviruses.
Yeah, true. All right. And then is this what we've seen today, the standard data analysis package, or is there an additional purchase needed for this kind of quantification?
All the software isn't included with the system. I would say only the compliance part, because not every user needs that. That would be additional, but all the rest is by default.
Yep. Is there another question has popped in, is there a size limit on the particles?
That would be like any DLS system. So I think 1 micron.
Yeah, the upper limit.
The limit.
Yep. Yeah, I think I've seen the same size limits from Stunner versus any other world-class DLS system out there. Okay, and I think we've reached the end of the list of questions here. Thanks for answering all those great questions, Nels, and thank you for a great presentation. I also want to thank all of you who joined us live today. If you'd like to have a deeper conversation with our team, please do get in touch with us at info@unchainedlabs.com or learn more from our website, unchainedlabs.com. We would love to connect with you and talk science. Thank you again for attending our virtual seminar, and I hope you have a great rest of your day.
Bye.